In this video, we're going to look at another application of trigonometric substitution. Here we're going to solve a definite integral. We have integral from 0 to 3/2 x cubed divided by 4x squared plus 9 all to the power of 3/2, integrated with respect to x. So we notice that we have variable squared plus constant squared. That is, we have 4x squared plus 9. So the pattern that we have is root of u squared plus a squared. The transformation we will apply is u is equal to a tan theta. Differentiate both sides, we get du is equal to a secant squared theta d theta. Derivative of derivative of tan theta is secant squared theta. So what we have is root of 2x squared. Notice we're writing 4x squared as 2x all squared plus, and we will rewrite 9 as 3 squared. This way we can fit it into the pattern above. So 2x will be equal to 3 tan theta. Differentiate both sides, we get 2 dx is equal to 3 secant squared theta d theta. So we can write 4x squared plus 9 to the power of 3/2 as 2x all squared plus 3 all squared all to the power of 1/2, and all of that raised to the power of 3. So equivalently, we can say that what we have is root of 4x squared plus 9 to the power of 3. So we can see where the root sign comes from. 4x squared plus 9 to the power of 3/2 is equal to root of 4x squared plus 9 all to the power of 3. Alright, so now we also have to change the limits. The lower limit is x equals 0. We plug that into theta is equal to tan minus 1 of 2x over 3. Plug x equals 0 in, we get theta is tan minus 1 of 0. What is arctangent of 0? That is just 0. Now let's put the upper limit, x equals 3/2. Plug that into theta. Theta is equal to tan minus 1 of 2x over 3. And we will get theta is equal to tan minus 1 of 2/3 times 3/2. That gives us 1. What is arctangent of 1? This is pi over 4. We obtained this from the 1, 1, root 2 triangle, the special triangles. Alright, so what we have is integral from 0 to 3/2 x cubed divided by 4x squared plus 9 to the power of 3/2, integral with respect to x, is equal to integral from 0 to 3/2 x cubed divided by 2x squared plus 3 squared all to the power of 3/2, integrated with respect to x. The transformation that we're applying is 2x is equal to 3 tan theta. Solve for x. X is equal to 3/2 tan theta, dividing by 2 both sides. And differentiate, we get dx is equal to 3/2 secant squared theta d theta. Now the numerator of the integrand is x cubed. So let's rewrite that in terms of the trig functions. X cubed is going to be 3 over 2 tan theta all cubed. Simplifying this, 3 cubed gives us 27. 2 cubed is 8. Tan cubed theta. What about the denominator? We have 2x all squared plus 3 all squared all to the power of 3/2. That gives us 3 tan theta all squared plus 3 all squared to the power of 3/2. So now we can we'll rewrite the integral 0 to 3/2 x cubed divided by 4x squared plus 9 to the power of 3/2. We can rewrite this integral, that is in terms of x, we can rewrite it in terms of theta. And that was the whole point of the trig substitution. So we have integral, we change the limits, the lower limit is now 0, The upper limit is pi over 4. And x cubed, that's going to give us 27 over 8 tan cubed theta. And the denominator is going to be 9 tan squared theta plus 9 all to the power of 3/2. And we have to multiply by dx. That's going to give us 3 over 2 secant squared theta d theta. All right, so what we have is, let's simplify this. We get 27 over 8, removing all the constants, putting them in front of the integral. 27 over 8 times 3 over 2 times 1 over 9 to the 3/2. We can remove that from inside the brackets. 9 to the 3/2 times the integral from 0 to pi over 4 tan cubed theta secant squared theta divided by tan squared theta plus 1 to the power of 3/2 d theta. Alright, so what we have is the integral from 0 to 3/2 x cubed divided by 4x squared plus 9 to the power of 3/2 dx, and by using a trig substitution we turn it into a trig integral that hopefully will be much easier to solve. So we have 3 over 16 times the integral from 0 to pi over 4 tan cubed theta times sec squared theta divided by tan squared theta plus 1 to the power of 3/2. But 1 plus tan squared theta is secant squared theta. We can use this trig identity. So what we get is 3 over 16 integral from 0 to pi over 4. The numerator remains as is, that's tan cubed theta secant squared theta. The denominator is going to be tan squared theta plus 1, trig identity, that's secant squared theta to the power of 3/2 d theta. We get 3 over 16 integral 0 to pi over 4 tan cubed theta secant squared theta. Now you can see that this square cancel with this one, so we're going to get in the denominator, we'll just have secant cubed theta. Now let's do a bit more simplification. We've got sec squared theta in the numerator, that cancels with the 3, leaving us with 1. So let's simplify this. We'll get 3 over 16 integral from 0 to pi over 4 tan cubed theta divided by secant theta d theta. Whenever you have an expression that has tangent and secant in the numerator and denominator, a good strategy is to turn tangent into sine over cos, and things will simplify. So we get 3 over 16 integral 0 to pi over 4 tan cubed theta, that's going to be sine cubed theta divided by cos cubed theta, and 1 over secant theta, that's just cos theta d theta. So we get more cancellations. Cos theta cancels with the 3 here, we get 2. So now what we have is 3 over 16 integral from 0 to pi over 4 sine cubed theta divided by cos squared theta d theta. Alright, so how do we solve this integral? We have integral from 0 to 3/2 x cubed divided by 4x squared plus 9 all to the power of 3/2 dx, and we basically simplified that through applying trig substitution and changing limits. 3 over 16 integral from 0 to pi over 4 sine cubed theta divided by cos squared theta d theta. How do we solve this integral? Well, we have a trig integral, and whenever you see an odd power of sine, you should factor out sine theta. So what we get is 3 over 16 integral from 0 to pi over 4 sine squared theta divided by cos squared theta times sine theta d theta. So what we get is 3 over 16. Now we're going to apply trig identity and write the numerator sine squared theta as 1 minus cosine squared theta. And you can see U substitution will follow afterwards. divided by cos squared theta times sine theta d theta. All right, so now we have a trig integral that's easily solvable by applying a U substitution, letting U be equal to cos theta. Then this part is going to get cancelled out because derivative of cos theta is minus sine theta d theta. All right, we're going to change the limits as well. So our new variable is U. U is equal to cosine theta. Its derivative du will be minus sine theta d theta, and we're doing a U substitution. All right, now the lower limit is theta equals 0. Plug that into U is equal to cosine theta. And what do we obtain? We get U is equal to cosine of 0. Cosine of 0 is 1. Now let's put theta equals pi over 4. Plug that into U. U is equal to cosine theta. That is our variable of substitution. And we get U is equal to cosine of pi over 4. What is cosine of pi over 4? To obtain this, you need to use the special triangles, the 1, 1, root 2 triangle. So cos of pi over 4 will be 1 over root 2. All right, so what we have is the integral 3 over 16 times the integral 0 to pi over 4, 1 minus cosine squared theta, divided by cosine squared theta times sine theta d theta. We made a change of variables. We let U equals cos theta. And so let's do all the mechanics of this. We get 3 over 16. The limits change from 1, lower limit is 1, upper limit is 1 over root 2. These are now U limits. 1 minus, and cosine theta is U, so that's 1 minus U squared, divided by U squared. And now sine theta d theta, that's going to be minus du. So I'll write du here and put the minus outside. So we have minus 3 over 16 integral from 1 to 1 over root 2. Let's split up the fractions. So we have 1 over U squared minus U squared over U squared, that's 1 du. That's equal to minus 3 over 16 integral from 1 to 1 over root 2. 1 over U squared, let's rewrite it as U to the minus 2 so we can reverse the power rule. Minus 1 du. That's equal to minus 3 over 16. Now split up the integrals, integrate term by term. What is the antiderivative of U to the minus 2? Add 1 to the power, divide by the same. U to the minus 2 plus 1, that's negative 1. Divide by minus 1. Minus integral of 1 is just U. And the integration is from 1 to 1 over root 2. Now let's apply the fundamental theorem of calculus and plug these limits in. Minus 3 over 16 times. Let's simplify this a little bit just so that it's easier to put the numbers in. So we have negative 1 over U minus U from 1 to 1 over root 2. All right, so now we have minus 3 over 16 times negative 1 over root 2 minus 1 over root 2 minus, now put the lower limit in, we get negative 1 over 1 minus 1. When this is all simplified, you will obtain minus 3 over 16 times minus root 2 minus 1 over root 2 plus 2. And this is the answer to the definite integral. All right, thanks.